Right. But imagine you're trying to build a human brain, right? But the only tool you actually have is an infinite filing cabinet. That is exactly what a massive chunk of the tech world is trying to do right now.
Yeah, and they're, promising you that you can run deep cognitive AI research on the cheap just using a basic Python script.
Right, so welcome to today's deep dive. Our source today is an article called AI Architecture versus Illusion, and it basically rips this delusion apart.
Okay, let's unpack this because there is a serious clash right now between naive coding and actual cognitive synthesis.
And you see that clash perfectly in a recent developer podcast called Nerd Snipe. The host there argued that deep research is basically nothing more than recursive retrieval loops. You write a script, hit a web API, grab some text, summarize it, and just repeat.
Too.
Yeah,
So
and it's not hard to make these flows. Like I've built out for myself similar deep research quote unquote flows for my own internal stuff. It's not that hard to make.
I mean, on the surface, that sounds exactly like how I do research. I search, I read, I summarize. So why wouldn't a script doing the exact same thing work?
Well, it ignores something called the information bottleneck principle. A true cognitive system doesn't just hoover up data, it compresses it. Oh, so it just throws away the norm.
Exactly. It throws away the noise to find the core predictive truth. But an API script doesn't compress anything. It just hoards.
So back to the filing cabinet analogy. You can shove thousands of papers into those drawers, but the cabinet itself isn't reading them. It's not connecting the dots. It's literally just holding paper.
Right. And if you just stuff the cabinet, you get what the source calls context rot. Unconstrained data actually destroys the focus of the model.
Wait, it actively destroys it.
Yeah, Anthropic actually measured a 39% performance penalty on complex tasks when models use those naive loops. The AI just drowns in its own, uncompressed bulk.
And then it starts hallucinating that disjointed slop we always see. But why exactly does it hallucinate just from having too much information?
Because it completely lacks entity resolution, meaning it doesn't realize two different phrases are describing the exact same thing, and worse than that, it has no stopping criteria.
Meaning it just doesn't know when to quit.
Exactly. It genuinely cannot tell the difference between, I haven't found the evidence yet, and this evidence simply does not exist.
Okay, so if the cheap filing cabinet method fails miserably, how do the frontier labs actually build a system that synthesizes? Here's where it gets really interesting, because they look to their founders' college dissertations.
Literally. I mean, let's look at DeepMind. Back in 2009, Demis Hassabis published his PhD on scene construction theory.
Right, the scene construction theory.
Yeah, he proved that the human hippocampus isn't just a hard drive. It's this proactive engine that stitches sensory fragments together to build a mental scene.
Wait, so when Gemini tackles the Deep Search QA benchmark, where it hits that crazy 93.3% success rate, it isn't just searching the web.
Not at all. It is actively mimicking that biological hippocampus. It takes multimodal fragments and binds them into a cohesive internal scene, and then it uses something called Monte Carlo tree search.
Hold on, stop right there. Monte Carlo tree search, what does that actually mean in practice?
So think of it like mapping out dozens of different conversation paths in its head. Before it executes a search or gives you an answer, it branches out.
Like mentally simulating the future outcomes of those paths.
Yes, it simulates those paths, scores which one is most likely to yield the truth, and then it only follows the winner.
Okay, so DeepMind solves the filing cabinet problem by basically building a biological brain that imagines scenes. But what do you do if your background isn't biology?
Well, you approach it like a theoretical physicist, which is exactly what Anthropic did. Their chief science officer, Jared Kaplan, also finished his PhD in 2009.
But not in biology, right?
No, his was in holographic field theory.
Okay, I'm definitely going to need you to translate that. How on earth does theoretical physics map onto a chatbot researching supply chain issues?
It is all about top-down constraints. So, in holographic theory, incredibly complex, chaotic dynamics, the bulk, they call it, can be controlled by a strict lower dimensional boundary.
Oh, so Anthropic uses constitutional AI as that exact boundary.
You got it. The Constitution forces the model's chaotic, massive parameter bulk to conform to a strict set of rules.
Okay, but how does that prevent the context rot you mentioned earlier where the model gets lost in the noise?
They use a technique akin to a physics concept called renormalization group flow.
Okay, in plain English, please.
Right, so imagine looking at a highly detailed, noisy photograph from an inch away and then stepping back 10 feet. The model essentially zooms out, to blur away the microscopic noisy data.
And it